Okay, ladies and gentlemen, you are welcome. So in today's video, we are going to look at the concept of chromatography. Introduction to chromatography. So what is chromatography? Chromatography is a laboratory techniques that used to separate mixtures into their individual components. So in chromatography is one of the separation techniques and is one of the basic laboratory techniques that used to separate mixtures into their component. And assuming now you have a mixtures of colors where you have red, green, yellow, and white together. So it is the role of all these chromatographic techniques. It is used to separate the components of the colors, to separate them into different colors. Well, let's say assume you have a solution containing a mixture of enzymes. Let's say you have hexokinase, you have proteinase key, you have glucose 6-phosphate, you have glucose 6-phosphate dehydrogenase, you have isocitrate dehydrogenase. So let's say it's a solution that contain different enzymes. So you can use chromatographic to separate the mixture of those enzymes into their individual component. And the principles behind this chromatography, it relies on the differential distribution of substances between a stationary phase and a mobile phase. So we have the separation of the substances or of the component of the mixture. It depends on the differential distribution of the substances. That is how they're distributed. So the differences in terms of their distributions between a stationary phase and a mobile phase is the basic principle behind the chromatographic techniques, because we have a mobile phase and we have a stationary phase, and the major role of the stationary phase and a mobile phase is to separate the component into um, and this method is widely used in chemistry, in biology, and environmental sciences for analysis and purification. And basically, we have many types of chromatography, but here we are going to discuss about column chromatography, vapor chromatography, and thin layer chromatography. So what are the history of chromatography? Chromatography was first developed in the early 90s by Michael Disvert, and the techniques was evolved significantly leading to various types suited for different applications. So we have different types of these chromatographic techniques, and this chromatographic techniques is suited for different applications. There are some chromatographic techniques, there are some types of the chromatographic techniques that are used for protein purification and isolation. Some chromatographic techniques can use for separating component of different mixtures. So the types of chromatographic techniques that you are going to use depend on the types of the substances that you are going to separate. Today, it remains a fundamental tool in analytical laboratories worldwide. So, chromatography is, as we discussed, is used to separate mixtures of substances into their component ions. So, sorry, into their components. So assuming now you have a mixture which comprises of many components. So it is the work of these chromatographic techniques to separate them into different components. As you can see from this diagram here, this is a mixture of ink. This is a mixture of ink. We have the mixture of ink here, and this mixture of ink will actually separate this component of the mixture, or this mixture of the ink, into different components. You see you have yellow and red. So as you can see clearly here, the yellow color separates itself from the red color and also the black color. So as I think if you can see, we have black, we have reds, and we have yellow. So after chromatographic analysis, the mixture of the color was separated into the three different components: the yellow, as well as the green, sorry, as well as the black and the red color. So this is a typical example of chromatographic techniques. So what are the basic principles of chromatography? So separation in chromatography is based on differences in affinity for the stationary and mobile phase. So components with high affinity for stationary phase tend to move slower through the system. So you see, one of the principles, like for example, for the affinity chromatography, you need a tag or a ligand in both the stationary and the mobile phase. So the component that has high affinity for the stationary phase, it will tend to move slower. So therefore, those that have the higher affinity will be retained in the column, and those that have lower affinity will be eluted. So the process allows for the identification and quantification of mixture components. So that is why sometimes we use elution buffer. So assuming now, let's say this is the protein of interest. This is actually this is the mixture. This is the mixture of proteins, as we can see from here, and this is the resin. So you need an affinity tag. So as we can see here, there are so many proteins, but look at it. This is the protein of interest. This is the protein of interest. So after you placed the mixture, all other proteins, because the protein of interest has or have higher affinity in the stationary phase of the affinity tag. So therefore, the protein of interest will be binded. So that is where there will be a slow movement through the system, while all other proteins that have lower affinity at the stationary phase will be eluded. So that is why here, these are the unwanted proteins that pass through the column, while the protein of the interests will be washed with the buffer, and also then to use water, to use wash buffer and the elution buffer. Then at the end, you have purified tag proteins, or you have purified, or your protein of interest will be purified, so it will be eluted last. So this is how to separate proteins based on the affinity. So this is a typical example of affinity chromatography. You need to buy, or you need to get a ligand that will bind to your protein of interest at the stationary phase. So the proteins that have, or the component that have the higher affinity will be binded to the affinity tag and will be binded to the column, will be binded to the stationary phase. And then those that have lower affinity will be eluted as shown here. So this is what we describe as affinity chromatography, and affinity chromatography is based on the binding affinity of the different components. So let's look at the different types of chromatography. So there are several types of chromatography, including thin layer and column chromatography, and each type of this chromatography uses different stationary phase and mobile phases that are suitable for specific applications. The choice of chromatography type depends on factors like the nature of the sample and then the desired solution. So you need to know how or what are the types of the solutions or the type of the substances you are dealing with, or the types of the mixture that you are dealing with. And based on that mixture, it will help you to choose a chromatographic type that is going to be applied. So that's why the choice of chromatography type will depend on factors like the nature of the sample and the desired resolution. So now let's start with vapor chromatography. So in vapor chromatography is a simple technique that used mainly for educational purposes and small-scale analysis, and it involves placing a vapor on placing a sample. It involves a placing of sample on a paper strip, and allow a solvent to move through it. And the separation occurs as components travel at different rates based on their solubility and affinity for the paper. So as you can see clearly here, this is a paper, and then you can add all the components of this hollow in one place. And then you now place it into a solvent, and the paper will move through it. And this component of the color will be separated into their individual colors based on their solubility as well as their affinity for the paper. So then the next one is still layer chromatography. So TLC, which is still layer chromatography, uses a stationary phase hotted on a flat plates, typically silica gel or alumina. It provides faster separation and better resolution compared to paper chromatography. And thin layer chromatography is commonly used for rapid qualitative analysis and purity testing. So this is a thin layer chromatography. First, use a stationary phase, which is coated on a flat plate. And it's usually, or it's typically silica gel or alumina. So the silica gel or alumina will coat the stationary phase. And after you do that, one of the very important things, this layer chromatography, it provides a faster separation and better resolution compared to paper chromatography. And it is used commonly for rapid qualitative analysis and purity testing. So then the next thing is column chromatography. So column chromatography involves passing a mixture through a column packed with a stationary phase, and it is widely used for purifying compound on a large scale. That is what we use. So if you have a mixture of compound and you want to separate the compound, so you apply column chromatography. As you can see, the column chromatography involves passing a mixture through a column packed with a stationary phase. So variations include gas chromatography and liquid chromatography, each suited for different sample types. So you should get that. So now, what is gas chromatography? So in gas chromatography, it separates volatile compound, get it? It separates volatile compound using a gas as a mobile phase. So a gas is used as a mobile phase and it separates volatile compound. And it offers high sensitivity and resolution for analyzing complex mixtures. And this gas chromatography is frequently used in forensic analysis, environmental testing, and quality control. So the next thing is liquid chromatography, which uses a liquid mobile phase to separate compound based on their interaction with the stationary phase. So the separation of the compounds is based on the interaction of the compound with the stationary phase. And then we have high performance chromatography, is an advanced form offering a high speed and precision for the separation of compound. And these techniques are essential in pharmaceuticals, biochemistry, and clinical diagnostics. So what are the applications and future trends? Chromatography is used in drug development, food safety, environmental monitoring, and forensic science. And advances in technology continue to improve resolution, speed, and automation of chromatographic method. So the future of chromatography include integration with mass spectrometry and miniaturization for portable analysis. So these are the applications of this chromatographic techniques. So ladies and gentlemen, please don't forget to subscribe and join to my YouTube community.